Hey everyone, and welcome. We rely on predictions for pretty much everything, from weather forecasts to the stock market. But what happens when those predictions go wrong? When the map you're using just doesn't match the world outside anymore. Well, today we're going to dive into a really cool case study about how to fix our predictions in real time when reality decides to change the rules. Let's jump in.
Okay, so I'm going to start with a kind of weird question for you. What in the world can watermelon season teach us about supply chain predictions? Yep, you heard me right. See, in the logistics world, watermelon season is basically code for a sudden massive shock to the system. Imagine a huge, totally unexpected demand for something like, you guessed it, shipping watermelons just explodes in one specific area. It throws all the forecasts and models completely out of whack.
And that right there, that's the heart of the problem we're talking about today. When a watermelon season hits, or really, when any part of the world changes fast, those predictions our fancy systems make can start to, well, drift. They just float further and further away from what's actually happening. What used to be a spot-on prediction is suddenly getting more and more wrong. And trust me, if you're not paying attention, you are in for a very rude awakening.
And here's what that drift looks like. Seriously, just look at that solid black line. It is a perfect and honestly kind of scary picture of what happens when this prediction bias is just left to run wild. See how it's not just a gentle slope? No, it's a full-on downward spiral. It just gets worse and worse over time. This right here is the villain of our story.
All right, so we've seen the damage. We know what the villain can do. Now let's really define this problem, and then, of course, introduce the hero that's going to fight back.
Okay, so the fancy term for this whole mess is bias drift, and all it really means is that prediction models naturally get worse over time. Why? Because the world changes. The data the model was trained on, that's yesterday's news. The new reality is, well, it's new, and the model doesn't know about it yet.
And the consequences in the real world, they're huge. If your predictions are drifting, it means you're always one step behind. You're too slow to react to what's actually happening out there. And that lag, it can cause massive operational headaches and, you guessed it, really unhappy customers start asking tough questions. It makes you look like you're asleep at the wheel.
But, like any good story, this one has a hero. And our hero is a really clever method called sequential shipment bias correction. The cool thing about it is that it's designed to fight this drift, not by ripping out the entire system and starting over, but by making these small, smart adjustments constantly, in real time. So, how does this correction machine actually work? Let's pop the hood and take a look.
It's actually a beautifully simple three-step process. Okay, so first, the system grabs a bunch of the most recent shipments from one specific area. Then, and this is the important part, it calculates a weighted average of how wrong the predictions were for those shipments, the bias. And finally, it takes that average error and just applies it as a correction to all the new predictions. It's kind of like you're constantly recalibrating your tools based on the very last measurement you took. Super smart.
Now that weighted average part, that's the real secret sauce here. It's so clever because it does two critical things. One, it puts more weight on the most recent data, what's happening right now. And two, it stops one single weird shipment from freaking the system out and causing a massive overcorrection. The whole point is to spot an actual trend, not just react to random noise. And this is just so elegant. Think about it. In any normal market, there are always little ups and downs, right? Just noise. By focusing on that collective average, all those little fluctuations just cancel each other out. The system sees it and goes, nope, nothing to see here, I'm not changing anything. It only jumps into action when a whole bunch of shipments start to be wrong in the same direction. And that is exactly how a real market shock like our watermelon season kicks off.
Okay, so the theory sounds amazing, right? It's clever, it's elegant, but the million-dollar question is, does it actually work in the real world? Well, let's look at the data. All right, this is it, the moment of truth. Remember that crazy downward spiral we saw at the beginning? The big question is, did this correction method actually fix it? Did it tame the beast?
And the answer is a massive, resounding yes. Just look at this chart again. That black line, that's the before, our prediction drift just plummeting. But all those colorful lines, that's the after. Those are the predictions with the correction turned on. Look at them. They're just hugging that zero bias line, holding perfectly steady. The drift is gone. It's been neutralized in real time. What a fantastic before and after.
And you don't even have to take my word for it or just look at the picture. The original paper says it perfectly, and I quote, "This drift correction effectively reduces bias drift to 0, and the greater the drift, the greater the correction." Think about that. It's a self-regulating system. The worse the problem gets, the stronger the fix becomes. That's beautiful.
This right here really puts it all together. So on the left, you've got the raw data. It's messy, it's noisy, just a chaotic bunch of dots, right? That's reality. But then, on the right, you see what happens when our correction machine gets its hands on that chaos. It intelligently smooths out all that noise and gives us that beautiful, stable trend line. It's literally turning chaos into clarity.
Okay, so we've established that it works, and it works really well. But let's zoom out for a second. Why does this technical stuff matter so much for the big picture, for the business itself?
Look, here's the bottom line. On one hand, you have uncorrected predictions. They're slow, they're super vulnerable to shocks, and you're basically gambling with your customers' trust. On the other hand, you have corrected predictions. Now your system is agile, it adjusts in real time, it's tough, it's resilient to those watermelon season events, and that protects the business. It's the huge difference between being reactive and being responsive.
Now, of course, this isn't some magic wand. We got to be realistic here. There are a few key things to remember. First, this method corrects for bias. It doesn't make the original prediction perfect. Second, it works way better when you have a lot of data to work with. You know, a high-density area. And finally, to keep the system stable, it's programmed to ignore the really extreme outliers. So yeah, it's a super practical tool, but it's not a perfect one. And that really leaves us with one big final thought. Because this isn't just about shipping or supply chains, is it? We live in a world that's changing faster than ever before. That gap between our computer models and actual reality is just getting wider and wider. So the question we're all left with is this: how do we build systems that are smart enough not just to predict the future, but to adapt when the future decides to go completely off script?